So to demonstrate convection in water, you've got to make sure the water is completely still, and then gently get a pasture pipette and gently lower it and deposit a small amount of red dye at the very bottom. So the most important thing is that you don't mix the liquid. So the liquid is going to mix, but by convection, not by you mixing it around. The second thing you need to do is grab some blue food coloring, ideally in an ice cube. And you can see I was a little bit careless and I dropped it and it started to swirl just a little bit, which is a bit unfortunate. And you can see that straight away some of the blue starts to drop. And so then I get the flame to the other side. And as you can see, I'm just demonstrating it with this simulation, the difference between increasing and decreasing the kinetic energy. So putting some heat on there causes the bonds to get excited, the molecules to vibrate more, and so it spreads apart. So this is actually thermal expansion for solids. And it's even more so for liquids and gases. So I'm just demonstrating convection. So this is only for liquids and gases. So in solids, they can't move. And so the particles get further apart from each other, and so they're less dense, and so they float. So the red goes to the top, and the blue's the opposite. They are not vibrating as much, so the spaces between the particles are less, and it drops. And you can see, so it causes a mixing. So up, the hot liquid goes up, and the cool liquid goes down, and so the heat is mixed that way. A lot harder to do for gases because you can't see the gases. So I've just come up maybe with this idea. If students are going to have a go at it, maybe just cut a hole in a can and put a slit on the side, and then wasted quite a few matches. I think you can see the smoke get sucked in. Instead of going straight up, it gets sucked into the hole there. Try to do that with a few examples. You can only just get whiffs of smoke. Not the most practical thing to do to try and demonstrate convection for the gases. Kind of a lot easier to do with liquids. And there's one there as well. It's a little bit easier, to be honest, to get the match and to actually bring the lit match close to the hole, and then you can see the flame get sucked in. And also because the flame's taking up all the oxygen, the flame on the inside is quite upset because it's not getting the oxygen it needs to burn properly. So that's proving that the gases are getting sucked in through the hole because the hot air is rising because it's expanding.